Welcome to the tutorial channel for the method of integral calculations. This channel is concerned for the integral calculation. In each lecture, we will discuss a certain subject in integration with illustrative example in a practical way, and we will see how to solve this integral step by step in a unique way. So let's start with the first subject, basic rule of integrations. We will discuss 3 points: the general form of integration process, the integration properties, we will see which type of properties that we have, and the last one, the importance of simplification for the function. Some function we are not able to make integrate for it until we make simplification for it, and we will see how we will do that. First of all, we all know that the integration is nothing but the reverse process of the differentiation. So, we will recall with each other the idea or the general law of the process of derivation only. As we know, there are several ways to derive for function, and that depend on the form and the type of this function. But to clarify the general idea, let's see this example. Find the derivative of the following function: y equal x to the power 3. To solve this kind of derivation, we are doing two main steps. We throw function exponent forward. We throw it, as you can see here. Then we subtract 1 from the exponent of this function, n minus 1. So we have two main steps to make the derivation for this function. We will throw the function exponent forward, 3 we will throw it, 3 we will throw it, and we will deduct 1 from this exponent. Simple way. But as we said previously, this was the general idea or form that we use to perform the derivation process. For the integration process, the process is completely opposite to the derivation process. So if we want to integrate the derivation function, we will get the general function. To clarify this in a practical way, let's see the next example. If we want to find the integral of the following function. To solve this kind of integration, we are doing two main steps. We increase 1 to the exponent of the function. So it will be n plus 1. We increase 1 to the exponent. The second step, we divide it by the new exponent. The new exponent, it will be redivided. So the solution will be, we will increase 1 to the exponent, so 2 plus 1 will be 3, and we will divide it to the new exponent, so it will be 3 by 3. And after the simplification, it will be x to the power 3 plus c for the constant. And this function will give us the original function that in the previous example. The previous integration process is also the general idea or the general form of the integration process. But when the type of the function to be integrated is different, for example, if it was one of the trigonometric function or logarithmic function, or if the function is a little bit complicated, then the integration method will be changed, and we will have to use another method or another way to perform the integration process, and this is what we will learn in this lecture. So we see the general form of the integration. We just increase 1 to the exponent of the function, and we will divide it to the new exponent. Let's go to see another point, the integration properties. the constant number can be taken out of the integral. As you can see here, constant number c, we can take it outside the integral. The integral can be distributed over the sum. If we have integral for the sum, we can distribute the integral over the sum integration for the function f and plus integration for the function g. Integration can be distributed over subtractions. Same concept. The integration we can distribute will be integral for the function f minus integral for the function. We can distribute this integral, it will go for this function, and this integral it will go for this function. Let's take another example in a practical way. Find the integral of the following function. How we will solve it? Notice the expanded form of the cube is this one. So first we will use this formula to expand the cube. We will apply it and we will get it this way. Later on we will distribute the integral to each function. As you can see, we will distribute this integral, we will go for this one, we will go for this. And later on we will use the general form for the integration. We will increase 1 in the integral and we will divide to the new exponent. 6 plus 1 will be 7 and we will divide it for the new. 4 plus 1 will be 5 and we will divide it to the new exponent. 2 plus 1 will be 3 and we will divide it to the new exponent. Plus, don't forget to put the constant c. This is just quick revision for what we discussed previously. Let's see another point. The importance of simplifying functions, especially when we're calculating the integral. Simplification is very important when we calculate the integration, especially when the integration function is difficult to calculate. Then we use the simplification to put the function in another form that make it easier for us to calculate the integration. And you maybe have noticed from the previous illustration that if we hadn't used the relation of the cube expansion, it will be hard for us to integrate the function. So the simplification is very important if we need to integrate for some function. The simplification that we will use it to put the function in different form to make the integration easy for us. So we will review the most important relation and famous method that we may be needed to help us to calculate the integration. If we need to use them, first one, square expand. You see, a minus b to the power 2. This is how we expand it. And be careful for the minus, and if it is a plus, it will be all a plus. Just be careful, be noticed for the plus. Cube expand. This is how the formula to expand the cube. Just be noticed, be careful for the minus. Here minus, so it will be here. Here we have minus. Also at the end we have minus. Okay. And the difference between two squares. This is also important. So a to the power 2 minus b to the power 2 equal to be a minus b multiply a plus b. These three formula you need to memorize it and keep it in your mind. Just if you need to simplify the function, you can easily use it. We have another simplification, the root of quadratic equation and the long division, but I will not discuss this at the moment. We will keep it when we need it for a certain subject. We will come back to it and we'll explain it. For the moment, just keep your mind these three formula. That will help you a lot to solve some integrals. So this is for today's lecture, and see you next time.